Hi. Usually, when the overhead tanks fill up completely, the water tends to overflow, indicating the tank is full. And by the time we go and switch off the motor, close to 2 to 3 liters of water is wasted each and every time. And if you calculate, close to 1000 liters is wasted annually. So using simple components, we can cut short this or even reduce it to zero using a simple circuitry and very few components. So in today's video, we're going to see how we can make a simple overhead tank water monitoring system to save both electricity and water. For this project, we'll need BC547 transistors, LEDs of any color, and few resistors. This is the circuit we're going to use today. In this, two wires go into the overhead tank, one from the positive terminal of the battery and the other from the base of the transistor. We used a 330 ohm resistor to limit the current going to the LED. From the two wires going into the tank, the wire from the positive terminal of the battery is kept all the way to the bottom of the tank, and the wire from the base of the transistor is kept at a level which is to be indicated. You can connect multiple such circuits to indicate different water levels. I connected 3 such circuits to indicate low, medium and full. We can add a switch at the positive terminal of the device to switch on only when we need it. The power supply to this circuit can be anywhere between 5 volts to 9 volts. You can also replace the LED with a buzzer to make a sound when the tank is full. I connected the base of this transistor to the first transistor, which indicates when the tank is full, so that when the tank is about to overflow, the LED will be on and also the buzzer will make a sound. You can connect an LED with 1 kilo ohm series resistor to indicate if the circuit is on or off. Now let's connect the circuit and check. Now let's test the circuit. Whenever I keep the two wires from the circuit into the water, you can see that the LED starts glowing. This is because the current flows from the positive terminal of the battery into the water and into the base of the transistor, switching it on. Though the water acts as a very bad conductor, the current flowing is very less and it's enough to switch on the transistor. Now I'll test the remaining stages of the circuit and also solder it on a PCB to make it permanent. So as you can see, I have soldered all the components onto the PCB. The 3 LED stages, the buzzer stage, the push to on push to off switch and the indication LED. I have also soldered 3 extra wires to the base of the 3 transistors, and I have also added a wire to the positive terminal of the battery. I have also added a 9 volt battery clip so that we can connect the battery to the circuit. I will be using wiring channel to make a support to hold the wires inside the water tank. I'll cut a length of 75 cm because the tank is of a height 75 cm. I'll make 4 marks on this channel, one at the end of the channel which will go at the bottom of the tank, one at the top indicating the water overflow, and 2 in between to indicate the low level and the middle level of the water. I'll punch holes at these marks using a thin screwdriver to fix the wires into them. I used twisted wires from the Ethernet cable to run from the overhead tank to the circuit board. You can use any wires depending on your comfort. The ends of the wires are stripped and fixed to the channel using the holes punched. The color of the wire can be used to identify while connecting the other ends to the circuit board. Now the channel is ready. I kept the channel inside the water tank such that it is straight and not inclined. I ran the wire all the way from the tank to the area downstairs where the circuit is fixed. The wires run from the overhead tank down here. Now I'll strip the ends of these wires and connect them to the circuit I made earlier. I have connected the wires to the circuit board, matching the color with the levels. I have also attached the battery and fixed the circuit board to the wall using some hot glue. Let's switch on the circuit and see. As you can see, none of the LEDs are glowing. That means now the tank is empty. Let's check this after some time. I switched on the motor for a while and filled the tank partly. And as you can see, the circuit is showing that the tank is half full. Let's completely fill the tank and then check the circuit. Now the tank is almost full. As you can see, the LEDs started blinking and even the buzzer is making sound now. So that was my overhead tank water level monitoring system. The circuit is very simple and it can be a very good weekend project. If you like this project, you might like my other projects too. Subscribe to the channel for my future videos. Until then, I'll see you in my next video. Thank you.